In this video, we're going to talk about how we can describe the patterns that we see in histograms. So individual variables, the patterns that we see in the values of those variables, we call those the distribution of that variable. Histograms allow us to see the distribution of continuous variables, and in particular, they show us the data density, right? They show us the values of that variable where we observe the most points. And that particularly allows us to describe the shape of the distribution. As we saw in a previous video, the width or number of bins that we set in our histogram can change the shape of that distribution. So it's important to try a few different bin widths and make sure that you're not accidentally obscuring the true shape of the distribution. So here are some ways that we might describe the shape of a continuous distribution. One thing we like to observe is what's called the modality. This basically means the number of peaks in the distribution. So if there's one peak, we would say it's a unimodal distribution. If there are two peaks, we would say it's a bimodal distribution. You'll note here that instead of drawing bars for the distribution, we've essentially just drawn a line. You can imagine this is kind of connecting the tops of each bin in the histogram. If we have more than two peaks, then we would say we have a multimodal distribution, and if there don't seem to be any peaks at all, right? If the height of every bin is more or less the same, then we would say that's a uniform distribution. The other thing we can describe is if we have a unimodal distribution with just one peak, is we can describe the skewness of that distribution. Does the data seem to be symmetric around the highest point, right? Evenly distributed on either side? Or does one side of the distribution seem to have a longer tail, right? We call the sides of each distribution the tail. If the long tail is on the right-hand side, we'd say it's right skewed, and if the long tail is on the left-hand side, we'd say the distribution is left skewed. So here are some examples where we can look at the modality of the distribution using a histogram. For each graph, let's take a minute just to think about how many peaks we seem to be able to find in the graph. What about this first one? This first graph, it looks like we have a unimodal distribution. We might think, well, actually, there's this what looks like a peak here and maybe a second peak here, but the overall trend is just for one peak, and it's likely that this lower bar here is just random variation. And we could test that by changing the width or number of bins and see if that disappears as we do that, or whether it persists, and that would tell us if this is actually a bimodal distribution instead of the unimodal distribution it appears to be. What about this second graph? Well, this one does seem to have two pretty distinct peaks, and so we would say this is bimodal. What about this third graph? This one, we seem to have three distinct peaks, right? One here on the left, one here in the middle, one here on the right. So this we would say is multimodal. The final graph has a relatively uniform distribution. There's no obvious peaks, and the height of most of the bins is pretty similar. The differences that we do see, we could probably ascribe mostly to just random variation. Let's do the same thing now, but for skewness. What about the graph on the left? Is this right skewed, left skewed, or symmetric? Well, this right-hand graph, the long tail is on the right-hand side of the center or peak. So we would say this is right skewed. The opposite case applies here to this middle graph. The long tail is on the left-hand side, so this would be left skewed. This final graph is reasonably even on both sides, so this would be symmetric. The other thing that histograms can show us is whether we have any unusual observations or potential outliers. So a point that seemed to fall a long way from the rest of the observations, we often call that an outlier. That's a good thing to be aware of because sometimes those can be points that, for whatever reason, are included in the data set, but maybe don't reflect the same um, process that generated the rest of the data. And so by identifying them, we might be able to make a judgment call about whether to include them in later analysis or not. So in summary, when we're interpreting a histogram, we want to note the shape of the histogram, right? Particularly the modality and the skewness. Also the center, where the highest bar seems to be. What is the value that it seems to be centered around, especially if it's a unimodal distribution? And finally, any unusual observations such as outliers.